Alright guys, so today you're taking notes on lesson 5. It's on Pascal's triangle and the binomial theorem. So make sure that you're writing that up at the top in the topic section. The date for you guys would be March 14th, and either you're putting block 4 or 6 up there. So Pascal is a French mathematician, and he discovered that there was a really cool relationship between all these values that we have in his triangle that he has. So they're giving us, and you will use this triangle, and I'll show you how we're going to use it. They're giving us some of the rows in his triangle. So our first row is called row 0. The second row is called row 1. The third row is called row 2, and so on. So Pascal's triangle always has 1s on the outside diagonals. So I've already filled in 1 and 1 here in row 4 and row 5 as the first entry, and 1 and 1 here in row 4 and 5 as the very last entry that we have. So his relationship that he saw after putting those 1s on the diagonal is any single entry inside of the triangle is equal to the sum of the two numbers diagonally above it. So this value of 2 was found by taking the value of this one, its diagonal up to the left, and adding it with the diagonal up to the right, that value of 1. So 1 plus 1 gets 2. Okay? This value of 3 was found by taking this value 1 and that value 2 by adding it together to get 3. So we're going to use these relationships to fill in all the other blanks that we have. So the value that's going to go in here, our fourth row, second entry, will be found by taking 1 and 3 and adding it together to get 4. The fourth row, third entry would be 3 plus 3. The fourth row, fourth entry is 3 plus 1, so that's going to get us 4. So here in our fourth row, it should be 1, 4, 6, 4, 1. The fifth row, first entry is 1. The second entry will be 1 plus 4 to get 5. The third entry will be 4 plus 6, so that's 10. The fourth entry is 6 plus 4, which is also 10. And then we're going to have this entry here will be 4 plus 1, so we're going to have 5. So in this middle section here, we're going to be expanding binomials. So taking two terms inside of some quantity and raising it to some power. So it could be to the 0 power, it could be to the 13th power. So what we're going to be practicing today is a quick way for us to expand out any binomial that we have besides foiling it and foiling it and foiling it and combining like terms. So the expansion here that you can memorize these. We're going to use these in a different way in a little bit. So we have a plus b to the 0 power. Clearly anything to the 0 power is 1. If you have a plus b to the first power, you would just have a plus b. And then you guys know that when you're taking any binomial and squaring it, the value that you're going to get out, and so on and so on. So the way that the Pascal's triangle is related to this expansion here, if you're looking here at a plus b to the fourth power, so take note at these coefficients. So we have 1, 4, 6, 4, 1. So the question is, have you ever seen that before? And the answer should be absolutely. Up here, 1, 4, 6, 4, 1 are all of the Pascal's entries for the fourth row. Same thing down here. A plus b to the fifth power, the coefficients are 1, 5, 10, 10, 5, 1. So look at that. 1, 5, 10, 10, 5, 1. So we can use Pascal's triangle to help us expand. So what we're going to write here, and what do you notice about the coefficients? They're symmetric. And form the nth row of Pascal's triangle.